When we look at Euler's equation through the lens of our convention, it just doesn't seem to make sense. E and pi are irrational numbers, which basically means that decimals seemingly go on forever, and I is an imaginary number. Its solution doesn't even really exist on the real number line. But when we multiply I and pi and raise e to that value, we get an integer. How does this work? What's the intuition behind it? And why is it considered as one of the most beautiful equations in mathematics? Let's find out. E, or Euler's number, has a special property where the value of the derivative of its exponential is the same as the exponential's value itself, wherein e raised to t is a function of t. Also, another variation of this property is this. Now if we replace c with I, we get this. Take real numbers. Whether they are rational or irrational, they can always be found on the number line. But if we square a negative or a positive number, we will always get a positive number. This causes the problem of there being no solutions for negative roots. To solve this issue, mathematicians decided to make a separate axis containing solutions to all negative square roots like the root of -1, or as it's commonly called I, and call this axis the imaginary number line. Now let's look at how I is represented graphically. When I multiply 1 by I get I, which means I moved exactly 90 degrees from 1. Multiplying with I again, I get -1, which is another 90 degree turn, and so on. So we see that multiplying something by I is analogous to moving 90 degrees anti-clockwise on a graph. Let's take e raised to it as a displacement vector. We know the derivative of displacement is velocity, and the derivative of e raised to it is I into e raised to it, which would be the value of the velocity vector. And because e raised to it is multiplied by I, and anything multiplied by I turns by 90 degrees, the velocity vector is perpendicular to the displacement vector for every value of t. But doesn't this setup seem familiar? It's circular motion. Hence, the position vector would trace out a circle as time passes by. Also, because e raised to 0 is 1, the radius of the circle would be 1 unit. Our starting point would be 1 and the destination would be -1. We see that the path the position vector will have to take is a semicircle. Its length is pi r, or in our case pi into e raised to it, as our position vector is the radius. Also, the velocity would be I into e raised to it, and the time taken to cover this distance would be pi into e raised to it by I into e raised to it. The e raised to it and I into e raised to it would cancel out as they have the same magnitude. This is because multiplying a vector by I just turns it by 90 degrees. It does not change its value in any way. Thus, we get e raised to I pi is equal to -1. That is the Euler's equation.